We will deal extensively with reaction mechanisms, in which we will show the movement of electrons in breaking and forming bonds. Recall from general chemistry that Bronsted-Lowry acids are proton donors and Bronsted-Lowry bases are proton acceptors. Consider the reaction between water and hydrochloric acid. While a proton does move from one molecule to another, it is the electrons that form new bonds. It is our goal to show how the movement of electrons yields the final products. To show the movement of electrons, we will use curved arrows. A double barbed arrow represents the movement of 2 electrons, and a curved arrow with 1 barb represents the movement of 1 electron. Notice that the reaction arrow and the resonance arrow are straight arrows, and they do not represent the movement of electrons. In this acid-base reaction, we want to show an oxygen-hydrogen bond forming and the chlorine-hydrogen bond breaking. To show this, we start with a lone pair of electrons on the oxygen atom and draw an arrow to the hydrogen atom. This means that there is a new bond between the hydrogen and oxygen atoms, represented by the green bond in the hydronium ion. To break the hydrogen-chlorine bond, we start with the bonding electrons and draw an arrow to the chlorine atom. These red-colored electrons are with the chloride ion now. Let's look at another example. Resonance structures are used to show when pi bonding electrons are delocalized. The acetate anion has the 2 resonance structures shown. To show the movement of the electrons, we identify where bonds have been broken and formed. Relative to the structure on the left, the oxygen on top has lost its pi bond and gained non-bonding electrons, and the oxygen on the bottom has gained a pi bond and lost non-bonding electrons. A moment's consideration will show that 2 curved arrows accomplish this movement of electrons. Notice that for resonance structures, we use a double-headed arrow because this is not an equilibrium reaction. The true structure is an average of the resonance structures.